Is this working? Oh, nice. Look at that. Actual AV people. So we brought our own laptop because, certain people don't know how to operate theirs. So today, Mr. Cooper and I are going to talk about high density and challenging designs. And the interesting thing is when you think of a challenging design, what's a challenging design? Somebody. Stadium. Somebody said a stadium, correct? That's a university. Well, it depends on the day, but yes. So when we were coming up with this talk, we had some real struggles because the title was going to be like this, and then I thought it might have been a little uncouth, but we're talking about directional antennas. So I'm going to tell you the most challenging designs today, as I just turned around and put my back to you, which is terrible, is actually basic office buildings and basic retail spots. Do we remember the green is good? Yeah. Guess what? We visit customers day in, day out, partners, distributors, and that's still happening. One AP for 800 people, because you can have so many associations on an AP, so why wouldn't you want that? Or our lovely, lovely capacity planning, where I need X amount of utilization on the AP, then I need 4 megabits per second per user at this point in time, and I end up with one AP every meter, 10 feet. So what we're finding is these are the most challenging designs that you find. I'm going to bring this up. Some of you, if you've seen this presentation, Peter did it, I think 2 years ago. It's basically the actual throughput going through the AP and the Ethernet on average. So this bottom line, 30 to 40 users, you're not even really breaking anything. So as we're talking about throughput, so the idea behind this is when we're talking about capacity, because we don't talk about coverage anymore, we talk about capacity, right? Coverage just comes with capacity. We kind of get over analytical in it to the point where we're not really doing this, and we're overthinking it. So what happens is I was going to do this with 6 gigahertz because we all want to see 6 gigahertz, but the gentleman who gives me this data is currently on vacation. And so if you see this presentation again, we'll have an updated chart with 6 gigahertz numbers, because I'm actually interested to see if it actually causes the change, because everybody's saying, ooh, Wi-Fi 7, we're breaking a gig. So that will be coming soon. So when we talk about directional antennas, I have been using external antennas indoors in office for years. It's a pain in the butt because you have to have special things to do it. You have drop ceilings, you have all kinds of custom mounting. But vendors have started putting directional antennas in an Omni-style AP. We have one, it's our 47D, it's a 60 by 60. I'm sure Cisco and all the other vendors themselves are starting to put these out. Because what we're realizing is Omnis really aren't good. You can't control RF, it goes everywhere, and it's an excuse for people to do bad design. So, in the fashion of doing live demos, because I like to do live demos and Cooper likes to do live demos, and we want to see if we can give ourselves more stress, we're going to try and do a demo. So, go ahead, Cooper.
Thank you, Rob, and thank you, everyone. So, in the spirit of the demo gods, hopefully this all comes through nicely for you all. So, someone mentioned universities out there as an example of a challenging design, and I'd agree with you, because this floor plan you can see here, it's a university. There's some high-density lecture theatres or classrooms, essentially, and this is a customer deployment that we had, as well as regular classrooms sort of spread out in this interesting fashion. So this is actually this centre area is actually a courtyard, so it's an open atrium. So this is up on the second floor of this particular campus building. So there's actually 3 floors, a very similar layout, and basically those windows look across a corridor out into an open atrium. So you can start to get a bit of a picture for yourself what this might look like from an RF propagation perspective. But essentially, exactly as Rob had mentioned, when they'd done their original design for capacity of X number of users at X megabits per second on, what sort of applications and devices they wanted to use, that's where they basically factored into placing omnidirectional Wi-Fi 6 APs on the ceiling, 4 per classroom, designed for capacity. Now, that's all well and good, but we can start looking at the heat map visualization of this design, and it looks pretty nice with the AP43s and a pretty regular power level there, and everything looks green, right? Only on this heat map. So let's now have a look at what happened. Actually, I'll just zoom in a bit more as well so you see. For capacity, they designed dual 5 gigahertz with 40 megahertz wide channels. They wanted speed on both radios. And that's all well and good. The AP Ethernet port can handle that. Can the Wi-Fi handle that? Not necessarily. So when you look at co-channel interference, and if it would help if I actually got the right floor plan, this is the before deployment. So this was the AP43s, omnidirectional antennas, even using a sort of mid-range transmit power level of 5 to 8 dBm, they were seeing their own Wi-Fi interfering with themselves because of the channel overlap in 5 gigahertz. They weren't using 2.4 gigahertz, so that wasn't really too much of a concern. But they were getting all of this co-channel interference across this entire high-density lecture theatre area, let alone on these other classrooms as well. And so the performance is terrible. We're tracking and missed the capacity from every single access point and from all the users as well. The client usage, the load of the clients per access point radio, but also what's the capacity of the RF available from Wi-Fi and non-Wi-Fi interference and the channel width and so on. So we were seeing problems in the dashboard, and this is how we basically illustrated to them that they're having their own problems from their own co-channel contention and overlap. And what I also wanted to make clear to them is just saying, you know what, you need to be a bit more specific about your transmit powers and when you're placing APs and considering you've got this open atrium area. This is all good for looking at primary and secondary coverage from a negative 65, negative 67 dBm requirements perspective, but they hadn't factored into what does that mean from a full signal propagation perspective of contention. Now, if you remember some of the other talks today about high density, recommended something that we are usually typically doing in high density networks is setting the mandatory basic rate or the minimum basic rate to 24 megabits per second. Everyone agrees that's pretty good for high density, right? You want to try and contain your cell edge of clients associating and not have all of the lower data rates out there to cause your own interference. Setting the 24 megabits per second data rates does not stop the signal from propagating. So the best way to show this is if I actually go into my requirements here for this particular design, and I can basically say, what do we want to set this to? Let's assume the signal detect threshold of minus 82. What does that look like? For one AP is basically covering the entire campus building across this open atrium and interfering potentially with these other access points on the other side of the building. And you can see the same thing here. These APs over here, 20 meters plus away, were interfering with the access points in this particular lecture theatre. So how do we fix that? We can't redesign the building. We can't make the walls thicker. So ironically, this is a university building with dry walls, not one of those complex ones where you have to design around heritage listed buildings with concrete and brick everywhere. That would actually be nice to help control the RF. So the best way to control the RF is move to using directional internal antennas. And so if we look at this particular heat map, I'll change these requirements back to what we want to with the negative 65. And then we'll just look at the propagation of a single access point here. That's nice and small. That's well contained. Even within these lecture theatres, this is quite well contained. And then even if we look at the signal cutoff, changing that back to negative 82 again for that signal detect threshold, we're going to see that we've now contained the RF enough that we're not blasting Wi-Fi all over the campus. And these APs are pretty well contained within this section of the building on the north wing, and these APs down in here in these classrooms on the southwest wing are fairly well contained. Now, the RF coverage down the atrium is another challenge, but this is basically helping all of these classrooms contain their RF properly, and then their co-channel interference is much better in that aspect. And you actually see this deployment is still using dual 5 gigahertz with 40 megahertz wide channels, because we controlled the RF. So, over to Rob to show another demo.
So, as Cooper did all the really technical stuff, I'm going to do something a little more simple, because it's me, and I like things simple. So when we start talking about doing office design, so I come back to offices because, again, doing most of what I do in enterprise, I go into people's headquarters. And we're now so we all agree APs go where people are, correct? Okay, thank you. So we're going to go ahead and take an AP47, because I don't use 43s. I only use Wi-Fi 7, so And we're going to go ahead and we're going to put an AP here in this lovely office building of about 300 people. We don't need the assistant planning, but thank you for the option, Matt. And then we're going to actually tune this down. 2.4 we're not going to use, but you know. But I think 14 is a little hot for an office. I like to usually sit around 8. So let's, come on, demo gods. Adjust, adjust. Oh, of course it doesn't adjust when I'm doing this. All right, so we're going to use 14 dBm because that's how that works. So what do you see here? In this entire plan, what do we see going on here? That one AP is covering the entire office. So if I walk in right here, I'm going to stay associated all the way back there. Because look at my coverage. I got green is good, right? So now what happens if we start taking a look at what if we change this AP to a directional AP? Come in here, let's change our model to directional. Now what do we see? Much tighter control. And it would be much tighter if I could use the power that I wanted to. So let's see if that actually works. Which I wholly believe it's not Matt, it is the Wi-Fi. So, not blaming you, Matt. Shh. Okay, so there we are at 8, so very good. So see how we're trimmed down here. See how we look at this. We've got nice coverage, we're looking at this. One of the cool things that we're not seeing here, and when you do an Omni design, is we kind of need roaming zones. You don't want green everywhere. You want demarcation zones. You need that client, because if I can see all these APs at neg 65, now your client's going to start going, oh, where do I go? You need a break in that transition. So what happens is you start to see and you're able to control your RF. So now I'm able to say, most likely when somebody walks in, they're going to catch this, and they're going to sit here. When they go up there, they're going to get that one. So what does this do for us? Not only are we allowed to have a better network, but you get the side benefits of what happens when you have an inexperienced designer or an architect who decides to just make the map green. You have a better chance of him accidentally making things okay than him just sprinkling omnis all over the place. Or if you're one of those people that still want to do that capacity plan where I need that 4 megabits a second, those 800 APs, you're at least not killing yourself with channel reuse. And a lot of places you'll see this in success is like, we'll take retail, for instance. Take like a Halfords or an M&S store. They're a box, right? Different size boxes, but they're a box. When you start designing with directionals, what you can eventually do is now you can actually do that 1 AP every X feet, meters, stone, whatever measurement you guys are using. And then now you're able to recreate that design simply, because let's be honest, there's no retailer in the world that says I have 1,000 big box stores and I'm going to let you do an AP on a stick survey. I'm going to let you design every single one of them. They're going to come back and say, that's not fiscally. I need you to give me this off of a predictive. So now you can go off and do a really tight design on one store and have a good value for doing predictives that are very accurate. Now, that's all I have.
Perfect. So we've shown some demonstrations on some best practices of what to do with some directional antennas to help control the RF. And if you remember Rob's opening statement about, green is not necessarily good, we don't want people to fall into the same traps of bad design in the past of 2.4 and 5 gigahertz and having the transmit power up too high. We're starting to get into the realm now of doing 6 gigahertz designs. So who here thinks it's a good idea to put 6 gigahertz up on full transmit power because it doesn't propagate as far as 5?
I'm just kidding, I don't.
Good, no hands raised. You passed the test. Okay, so just because we're designing for 6 gigahertz now, maybe you don't get the chance to do a proper redesign, you're doing a rip and replace. You might have to fill in some coverage gaps, but we just want to say the same rules apply. When we're talking about controlling RF, it doesn't really matter whether we're talking about 2.4, 5, or 6. We still want to optimize that use of the spectrum and not cause our own co-channel interference. So the good thing for the US and Brazil and other countries that can use this full 1.2 gigahertz of spectrum and 6 gigahertz, they have a lot more channels that they can use. So they're either using 40 megahertz wide channels or potentially even 80 megahertz wide channels as a default in their RF settings and radio resource management. So we're not so lucky here yet in Europe.
I was going to say, and if you don't like that, go talk to a man named Dobius. He's joined like some kind of committee to try to fight that. And he would definitely probably take your time because we all want that 1200 megahertz of spectrum.
Yeah.
Oh, sorry, go ahead. I just saw you're here and I'm going to pull it out because you called it out the last time you spoke.
Yeah. So until Ofcom and ETSI and the EU approve this upper band, which is hopefully going to happen in the next 12, 18 months or so, we have to be a bit conservative when it comes to things like dual 6 gigahertz. So, our AP47 could do dual 5, it could do dual 6, but dual 6 is not really useful until this upper band of spectrum is completely opened up, especially when you want to take advantage of cleaner spectrum with wider channels too. So keep this in mind. These features are available, but use them sparingly. Don't go crazy doing super wide channels. And the other aspect is what to do with your SSIDs. So, data rates is one thing about controlling the RF, but you do still have to understand what's happening from the signal propagation perspective, which I illustrated in the demonstration there. A lot of people are still uncertain about how to transition to 5 and 6 gigahertz and WPA3, whether that's enterprise for .1x or whether it's SAE, like Lee was talking about earlier. So the strategies that we've seen being most successful in environments is making sure that you've got SSIDs on both frequency bands. It doesn't have to be the same SSID, but ideally you'd have your 6 gigahertz and 5 gigahertz radios propagating SSIDs and broadcasting them so that you can use reduced neighbor reports. I've seen so many customers where they've tried to do some proof of concepts for 6 gigahertz capable clients, and they've configured a 6 gigahertz only SSID, and they've gone, "Coops, I can't see the 6 gigahertz." I'm like, because your client doesn't know how to discover it. It's scanning and probing on 2.4 and 5, and it's barely giving any time to scanning any 6 gigahertz wide channels, because there's just so many channels available in 6 gigahertz. Most clients aren't scanning those. So if you have 5 and 6 gigahertz enabled, then you can make use of reduced neighbor reports, and most clients are going to use those to associate to. Your mileage is going to vary depending on transition modes and what flavors of new security methods you can support, whether it's enhanced open for open networks, whether it's SAE for pre-shared key networks, or whether it's WPA3 enterprise on the .1x side of things.
And remember, transition mode is not your friend. It's a migration path, not a permanent strategy.
It's not a permanent option. And then when it comes to those data rates, again, your mileage may vary. You have to test your client fleet out as well, see what they like in terms of data rates and what you're doing with transmit power, and also keep in mind that whatever channels your radios are operating on, whether it's 5 or 6 gigahertz, your data rate settings do actually influence the other SSIDs broadcasted from that radio. So you might be setting compatibility for an IoT SSID that's on 2.4 and 5 and allowing all of those legacy 802.11b and G rates. That's actually impacting those same SSIDs on the same channels that you might still have set at 24 megabits per second. Yep. Your clients are still going to contend with each other on the lowest possible rate that is configured on those on those radios and that network. So with that, we want to then help people avoid mistakes like this. One of the reasons this university customer I showed before didn't go with external directional antennas, even though we recommended it, was to save on cost. They wanted to reduce the cost of the installation. They wanted to standardize with the same AP43 omnidirectional antenna AP everywhere. And then they paid the price for it once it actually came to crunch time and they had those classrooms full of students. But we do also want to avoid bad installation mistakes. So when you think about you have an internal directional antenna for those use cases, there's less things to go wrong in that deployment. You're not placing an antenna where the AP should be and vice versa, and you're not placing the AP somewhere in the ceiling where it shouldn't go as well. Any comments on this, Rob?
Oh, I was going to say, the funny thing is these are actual customer deployments.
Yeah.
I hate to say it. These are brand new deployments, too. Not like you walked in and like, oh, I'm coming to fix it. You're coming to validate. So validation is important. Because no design can survive a cable installer. Sorry. Proof's in the pudding.
Yeah.
But yeah, so just as you're doing this, guys, remember, this is as much as an art form as it is a science. And if we go too far into the science, sometimes we get lost in the weeds that cause us to start doing bad things. So new things like the directionals being built into the Omnis have really kind of given us another tool in the arsenal. So just think about it when you're doing it, that there is no, well, let me rephrase it, there is a wrong and a right way. But there is really, you have a lot of flexibility as long as you design and you understand your requirements and you don't go too far.
Yeah. And we're not saying don't use external antennas, just you don't
Yeah,
necessarily
we
need
love
to use
external
them
antennas.
everywhere.
Where are they? Yeah.
Yeah. And so, so the great thing is that, we partner with Axeltex. So see Matt and the team here from Hubble Axeltex. They built the antennas for us as well. So different use cases for patch and omnidirectional antennas, warehouse use cases, and they all work with the AP47E series that we've got for 6 gigahertz, and they're available in Ekahau as well.
And they also make proper brackets so you don't end up like this.
Yeah. So obviously you can't show this in Ekahau how you want to install it. That's up to doing installations for your installers to do that properly. But with that, hopefully you'll run into less of these problems. So thank you very much.